Hi everybody, my name is Meredith Chaput and I am a third-year PhD candidate at Ohio University. Today I'm going to talk to you about our paper, Visual Cognition Associated with Knee Proprioception, Time to Stability, and Sensory Integration Neural Activity after ACL Reconstruction. I'd like to thank all my co-authors for this work on this paper as well. So after ACL reconstruction, we see that there are widespread brain changes that occur. These tend to be concentrated in regions that are important for memory and visual memory processes, as well as cognitive control of movement. So our overall goal for this paper was to determine what is the neural change associated with a clinical metric of proprioceptive function, but also stability and cognitive function that we know might be related to this injury and recovery in some fashion. So we assessed individuals' proprioceptive ability using an active joint position sense, where they had to extend their knee out to 20 degrees, memorize where that angle was, and then reproduce it on their own. And our error was the difference between the target and reproduction angles. Then we had them do a dynamic stability task, where they had to stabilize from a jump landing. So they were to jump up to a height 50% of their max, and then stabilize on one leg as quickly as possible. And then we were interested in the resultant of how fast they were able to stabilize from this jump landing. We also measured their neural activity during a kicking task. And what we found was pretty interesting. So in our cohort, we had ACLR individuals and also individuals who were healthy. And what we found was that in all of these metrics, there was no difference between our healthy individuals and ACLR individuals' performance. However, the relationships with cognitive function as well as neural activity were different. So in ACL individuals only, people's visual memory and proprioceptive scores were correlated, as that individuals who had lower proprioceptive error also performed better on visual memory assessment. And then individuals who were able to stabilize quickly from a jump landing had better visual motor ability. When we look at their neural data, we found that only in the ACL individuals, their cognitive function was related to two regions, the precuneus and the posterior cingulate cortex, which are highly engaged in cognitive and visual awareness of movement. So what does this mean for clinicians on Monday? This means that in our rehabilitation, despite lots and lots of time, exercise, and return to sport, that our individuals after ACL reconstruction have pretty significant neural changes, and they could be using these strategies to compensate on clinical metrics of function. Therefore, some intervention ideas might include dual tasking and integrating motor learning differently in our interventions to help mitigate these compensations.